basic power supply.
Power supply is a device that converts AC to unregulated DC. This is important because aside from converting AC to DC, power supply also corrects the electric current coming from the source. So the components that we used in the simulation are AC voltage, transformers, diodes, filter capacitors, and resistors. So AC voltage or alternating current voltage is an ideal voltage source that periodically changes its polarity. Meanwhile, transformers are used to change the amount of the voltage and current of a source while remaining its normal frequency. So there are two diodes used here. The first one is the normal diode and the next is Zener diode. Normal diode can only work if the circuit is forward biased. These diodes are used in clippers and clampers. On the contrary, Zener diodes are used in voltage regulators and they can work on both forward and reverse bias circuits. Filter capacitors. These are the type of capacitors that are used to reduce a certain amount of frequencies present in a circuit. These capacitors filter out the DC signals found in a circuit and let the AC pass through. Lastly, resistors are electric components that are known to resist the flow of electricity in a circuit. This video will show you how these components work together in an electric circuit.
Here's our sample circuit of the basic power supply. Our simple power supply consists of an AC voltage, a transformer, a rectifier, a filter capacitor, and a regulator. As seen in the picture, this is a full-wave rectifier power supply with the components of the AC voltage, a transformer, a diode, a filter capacitor, a resistor named R, a resistor named RL, and a Zener diode. The AC voltage is set to 220 volts. The transformer is set with a P turn of 12 and a S turn of 3. The filter capacitor is set to 1500 microfarads. The resistor R is set to 2.149 kilo ohms. The resistor RL is set to 500 ohms. And the Zener diode is set to 25 volts, which will produce a DC output voltage of 10 volts. Here are the measured values of the basic power supply.
This is the schematic diagram for our circuit, and you can see here the AC voltage source, the diodes, the capacitors, and the resistors. We need to find the values for the transformer, rectifier, filter, regulator, and output. And to do that, we need to attach the current and voltage probes. So first, we will attach the voltage and current probe here to find the value for the transformer and set it to periodic. Next is to find the rectifier. We'll attach again the voltage and current probe. And for the filter, and lastly for the regulator and output. And now we got the values. So this is the table for the values. So the transformer has a voltage of 55 volts, rectifier 53.36 volts, filter 0.60 volts, regulator 20.14 milliampere, and for the output 10.07 volts.
So here's the waveform of a DC output voltage.
We use the grapher in multisim to see the waveform of the DC output voltage from the previous circuit. So this waveform describes the nature of a DC voltage source, which is the voltage across it is constant as is the current through a DC current source. You can see that as the time increases, the voltage increases as well. However, when the voltage reaches at approximately around 10.10 volts and at time 4.60 milliseconds, it stopped from increasing and is in constant direction. The flow of the waveform of DC output voltage is unidirectional, and also it means that it does not periodically reverse its direction.